Hi everyone, my name is Julie and I'm a member of the FreeFlyer technical support team at AI Solutions. Today I'm going to be talking about one of the simplest but most important aspects of any mission, contact analysis. For this discussion, we're going to review the Chain Visibility Sample Mission Plan. This mission plan analyzes contact times between multiple ground and space assets. As you can see in the 3D view, we have ground stations located in Madrid and Canberra, 6 satellites in the Tigris constellation, and a single generic satellite simply called Spacecraft 1 in a 15,000 kilometer orbit. We define the chain of contact as complete when Canberra has contact with Spacecraft 1 is in contact with one or more Tigris satellites, and those Tigris are also in contact with Madrid, all at the same time. When the chain is complete, green vectors are drawn in the 3D view to illustrate the path of the data transfer. The visibility is indicated in the plot in the top half of the window, and the contact start and end times are reported to the console. So let's dive into the script behind this sample mission plan to understand exactly how we can build this analysis in FreeFlyer. You can browse FreeFlyer's extensive suite of sample mission plans by clicking Browse Sample Mission Plans from the home screen. This one is located in the Coverage and Contact Analysis folder and is called Chain Visibility. On the left side of the screen, in the object browser, we have our 2 ground station objects, Canberra and Madrid. These are both defined using the station geodetics file, meaning that we pull information from that file to configure the ground station's physical location and mask shape. We also have Spacecraft 1, which is configured in a simple, generic circular orbit with a semi-major axis of 15,000 kilometers. Also in the object browser, we have 2 arrays called Pre-Visibility and Visibility. These each contain 6 elements to represent the state of contact between Spacecraft 1 and each of the 6 Tigris satellites. In our mission sequence, we have a number of freeform blocks that contain FreeFlyer script, as well as a while loop that sets up propagation for just a little less than a full day. Freeform 2, called Create Objects, is where we set up our Tigris formation and the objects that we'll need to use for our contact analysis. First, we create 6 variables to represent visibility through each of our Tigris spacecraft. These variables will be used to generate our plot. Next, we create the Tigris formation and configure the 6 spacecraft in geostationary orbits, adjusting the right ascension of the ascending node property for each to set them in different locations along the circular orbit. Next, we set up the visibility calculators, which are the most important part of this mission plan. Visibility calculators and visibility segments are essential components of contact analysis in FreeFlyer. The visibility segment object is a tool used to evaluate whether line-of-sight contact can be achieved between an observer and a target, and the visibility calculator object is a handy way to evaluate multiple visibility segments at once. Here, we set up 6 visibility calculators, 1 for each Tigris, with each calculator containing 3 visibility segments. First, we set the visibility requirement property of each calculator to 0, meaning that all active visibility segments in the calculator must have visibility in order for the calculator itself to have visibility. If we were to set this property to 1 instead, the visibility calculator's visibility method would return true if any of the active segments had visibility. After setting the visibility requirement behavior, we configure each visibility segment individually. We create new visibility segments and add them to the visibility calculator using the add segment method, then configure the observer and target for each segment using the set observer and set target methods. We can also add occulting bodies to the visibility segment using the add occulting body method. Here, we see that the first segment defines the Canberra ground station as the observer and Spacecraft 1 as the target. The second segment defines Spacecraft 1 as the observer, a single Tigris satellite as the target, and sets the Earth up as an occulting body. And the third segment defines the Madrid ground station as the observer and the current Tigris as the target. The visibility calculator.visibility method will return true only when contact is achieved for all 3 visibility segments, meaning the chain from Canberra to Spacecraft 1 to Tigris to Madrid is complete. In the last part of this freeform, we configure a number of vector objects between the ground stations, Spacecraft 1, and the Tigris network. These vectors are only shown in the 3D view when the full chain of contact is achieved, and are a great visual representation of our visibility calculators. In Freeform 3, we create and configure our output, which in this case includes a plot window and a view window. The plot window has elapsed time on the x-axis and the 6 visibility variables for y values to represent when the visibility is achieved through each TDRS. The view window is a 3D view that contains spacecraft 1, both ground stations, and all 6 TDRS satellites. Now that we've gotten everything configured, we can begin propagation by entering our while loop. Freeform 5 is executed at the beginning of each iteration of the while loop and is where we update all the output to reflect the current state of the visibility chain. First, we make all the vectors invisible by setting their active property to 0. Next, we evaluate each of our 6 visibility calculators by checking the result of the visibility method. If it returns 1, that means the chain from Canberra to spacecraft 1 to the TDRS to Madrid is complete, otherwise the method will return 0. If visibility is achieved, we turn the appropriate vectors visible in the view by changing their active property to 1. We also have some logic to check whether this is the start of visibility by comparing the visibility array with the pre-visibility array. If the contact chain was not complete in the previous step, we report the start of contact time out to the console and update the pre-visibility array to keep track of the current visibility status for comparison at the next time step. Similarly, if the visibility chain is not currently complete and it was complete at the last time step, we report the end of contact time to the console. Finally, after iterating through all 6 visibility calculators and storing the current visibility status in the visibility array, we copy the elements out of the visibility array into the 6 visibility variables that we're using for the plot window. Note that you can also plot the array values directly in the plot. We're just using the variables in this case to simplify the names displayed on the plot without having to directly adjust the labels. The plot will show a value of 1 when visibility is achieved, and 0 when it is not for each TDRS. Finally, in Freeform 6, we update the view and plot windows with the latest data and step our TDRS formation and spacecraft 1. This analysis and propagation will continue until the while loop's condition is met, so when the elapsed time equals 0.93 days. Now, when we run this mission plan again, we have some great insight into exactly what's going on. Whenever all the segments of any visibility calculator are satisfied, the appropriate vectors are shown in the 3D view, and the plot shows a value of 1 for the appropriate TDRS spacecraft. Whenever a contact window for a visibility chain begins or ends, the time and affiliated TDRS are reported out to the console window. This concludes our review of the Chain Visibility Sample Mission Plan. For more information on visibility calculations and chain visibility, you can review FreeFlyer's help file under Guides, Coverage and Contact Analysis, Visibility Calculators. If you have any questions, you can reach out to our technical support team by email at techsupport@ai-solutions.com or by phone at 301-306-1756 extension 2.